Welcome, students. Today we are going to begin a lesson about Intro to Geometric Solids. So in your math notebook, I would ask that you record this label here at the top of your next clean page, Intro to Geometric Solids. We're going to learn about what these are, these geometric solids. So we have already been studying geometry and geometric shapes. And to begin with, I'm just going to use a real simple and familiar one. That would be a rectangle. And a rectangle, we can say, has two dimensions. This is a word we're going to be using here a little bit. It has a couple dimensions. One of those dimensions is its length, what we might call the base. Another dimension we might use to describe it is its width. How wide is this rectangle? Now, if I take this rectangle and, so we can say that it has two dimensions, length and width. Now, not all shapes in the world are made up of only two dimensions. In fact, when you look around, the things that you see looking around your room are not only two-dimensional. They don't only have length and width. They actually have a third dimension. Now, if I take this rectangle and I lay it flat on the ground, let me show you what it looks like when I lay it flat on the ground. This is kind of cool. Now, if I take this rectangle that I've laid flat on the ground, I can actually create a three-dimensional shape, and I'm adding a third dimension. So our rectangle here, it already has length and it has width. But I can add a new dimension here, right here. This new dimension is called height. Height is a third dimension. We can say that shapes that have three dimensions are three-dimensional. In fact, you might have seen that word before, 3D. That's what 3D means. It means that it has three dimensions, length, width, and height. So we're going to be working with three-dimensional shapes here. And to begin with, we're just going to learn about how to identify different three-dimensional shapes, shapes that have width, length, and height. So in our last video, we talked about how two-dimensional shapes have width and length. But we see here how we can fold up a two-dimensional shape and add height. In this case, we've folded up those sides to make a pyramid. We call that three-dimensional. Now, three-dimensional shapes are made up of three parts. The first part of a three-dimensional shape is a face. A face is a surface, and these surfaces are contained between something we call edges. A face is a surface that you might be able to lay this shape on. That's the face there. Now, the next part of a three-dimensional shape is an edge. An edge is a straight line where two faces of a solid shape meet. If you can imagine holding a knife, the edge of the knife would be sharp, whereas the flat sides of the knife would be the face. Now, the last part of a three-dimensional shape is a vertex. A vertex is a point at which two or more of those edges meet. On a knife, the vertex would be the point, the sharp point at the end of the knife. Now, vertex, that starts with that letter V, and I kind of remember what a vertex is just because I remember that V is sharp and the vertex is kind of the sharp, pointy part of a shape. When there's more than one vertex, we call it vertices. That's the plural of vertex. So this particular shape here has a few vertices. Those three parts are those are the three parts of any three-dimensional shape: the face, the edge, and the vertex. In the next part of this lesson, I am going to help you identify the faces, edges, and vertices of a few three-dimensional shapes. To begin with, we're going to look at this shape here, this three-dimensional shape. Now, this shape is called a rectangular prism. It's rectangular because its base is a rectangle. You'll notice that here the base is a rectangle. It's a prism because the bottom is the same shape as the top. It does not change the whole way through the shape. We can also identify a rectangular prism by the number of faces, these flat sides, and edges, these kind of sharp edges here, like the edge of a knife, and the vertices, these points here. Imagine the tip of that knife. That would be the vertex. So we can identify a rectangular prism because it has 1, 2, 3, 4, 5, 6 faces. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges, and 1, 2, 3, 4, 5, 6, 7, 8 vertices. That is a rectangular prism. Now, there are other kinds of prisms as well. This is an example of a triangular prism. Now, a triangular prism, it's a prism as well because the base is also the base is a triangle. The bottom of the shape is a triangle. See here? But and the top is also a triangle. It's a triangle the whole way through. Triangular prism because the base is a triangle. And here again, we can identify it by the number of faces, the number of flat sides it has, the number of edges that it has, and the number of vertices that it has. That is a triangular prism. Now, there's another type of three-dimensional shape as well. That is a pyramid. Now, a pyramid has a base, just like a prism does, but you'll notice that with the pyramid, as we go up, the shape actually changes. The base is a different shape than the top of the shape, which is actually called the apex. Apex is like the top of something. So notice that the top, the apex here, it's just one vertex where everything meets. And the base is a rectangle. So we call this, you might recognize this shape, it is a pyramid. And we call it a rectangular-based pyramid because the base is a rectangle. Now, not all pyramids are rectangular-based pyramids. We can also make a pyramid whose base is a triangle. Now, this is an example of a triangular-based pyramid. And here we can see that the base is a triangle. And as we go up, the faces all meet at one vertex at the top. There, that little pointy part there. So this is a pyramid as well, and we call this a triangular-based or triangle-based pyramid or triangular pyramid. Now, not all three-dimensional shapes have flat sides. This is an example of a three-dimensional shape that does not have a flat side. It has this curved side here. So we don't actually count that as a face because it is not flat. We say that this shape has two faces, the bottom and the top. And it's kind of like a prism because the bottom is the same shape as the top. We call this a cylinder. A cylinder is a shape whose bottom and top are the same size, and it has one kind of round face all the way around it. But we say that it has two faces. 1, 2. It has 0 edges because there are not any faces meeting each other, and it has 0 vertices because there are no edges meeting each other. So it's a shape with 2 faces and 0 vertices and 0 edges. Now, next up, we're going to look at a shape who has a round base, but whose base on the bottom is different than the top. In this case, it meets at this vertex at the very top here. So we can say that this is a cone. A cone has a flat base, one face on the bottom, and 0 edges and 0 vertices. There's no real vertices because there aren't any edges to meet each other. And so this has only one face. Now there's a shape that has no faces. That would be a sphere. Now a sphere has no faces at all. Let's see here. Oops, sorry. A sphere has no faces at all. In fact, because it has no faces, it also has no edges and it has no vertices. Now, and no matter where we kind of slice it, it's going to be different. So it's a different size at any point that we slice it here. It is perfectly symmetrical. That means that if we slice it, that little slice in the middle there is going to be perfectly symmetrical. We can cut that right in half, no matter how we slice it. So that is a sphere with no faces, no edges, and no vertices.